Today, lithium-ion battery cells for battery electric vehicles come typically in 3 different formats in various sizes, but also different electrochemistry depending on the application and choice of the vehicle manufacturer. The different cell formats contain more or less the same elements, which are arranged differently, i.e. the layers of anodes, cathodes, and separators can be found wound or stacked in the cells. For the required high voltage battery of battery electric vehicles, the cells are connected in a way to provide the power and energy capacity needed for the intended use of the vehicle. Car manufacturers follow different philosophies in terms of performance, safety, reliability, and cost, and may use different cell types. On one hand, prismatic cells, where the battery is actually contained in a protective housing that adds additional safety, offers a standardized packaging size, but also adds weight. Then the pouch cells, which offer different cell shapes and also comparatively low weight, but they are less well protected. And then cylindrical cells, which can be produced at lower costs and are well known to the industry from the electronic industry. Now, in terms of testing, all the cell materials for these cell types are tested following similar test procedures. So the information on the following slides is valid for all cell types. We, as a manufacturer of mechanical testing equipment, provide testing solutions in 4 testing areas. Materials testing, where we characterize the materials' properties that are important in battery elements like electrodes, separators, coatings, tabs, wiring, packaging, etc. Structural testing, where we test the supporting or enclosing structures that give the cells, modules, and packs its strength and resistance against external damage. Functional testing, where we investigate the mechanical and electrical performance of cells during charging and discharging cycles, as well as in extreme situations. Abuse testing, where the behavior of cells, modules, and packs under abuse conditions is investigated. Typically, batteries cannot pass the tests when they show flames, fire, or explosion. A quick look at the structural testing. So here we're looking at cells, modules, and packs, cables, connectors, structural elements, tab wells, and so on. And here we typically look at applications which exert a force range, or which are in the force range of 100 newtons to 150 kilonewtons. The types of tests: structural strength, joining strength, terminal shear strength, the strength of electrical connections, welds. And here we have some examples. On the left, you see a terminal shear strength test, then a flexure test on a prismatic cell, then XYZ tensile test on a tab and a welded tab, and later on at the last slide, at the last picture, you see a structural test on a module structure of a battery pack. Looking at the functional tests, here we look at electrode and electrode coating conductivity under different loads. We look at cell deformation during charging cycles. We look at electrical cell performance under mechanical loading. And here typically we also see force ranges between 100 newtons and up to 30 kilonewtons depending on the test application. Here an example. On the left side you see the conductivity test under load between of a coated electrode, and then you see a compression test on a battery module stack. On the right side you see the possibilities that we have with our software, because we can not just measure force, deformation, time, but we can also incorporate other signals from the battery cell. For example, from a battery analyzer, we can read in voltages, we can read in temperatures and other data or other signals. And you see in the graph that we can superimpose them and actually get a very good picture of how a cell is, what is happening inside a cell during a mechanical loading. So as here the mechanical loading increases, at one point the cell goes into a short circuit, so the cell voltage drops. At the same time, the cell temperature increases, and all this can be documented and recorded with our system. Then we come to the abuse tests. Here we're looking again at cells, modules, and packs. Here the force ranges are higher because if you want to crush a module or a pack, you need higher forces, and also 150 kilonewton may be okay for the module range. But if you want to actually deform mechanically larger packs, you need higher forces, even going up to 600 kilonewton. So typical tests are nail penetration tests, crash impact tests, crush tests, and the abuse tests are actually the only test group or test area where which is highly standardized. The safety tests are well standardized with international organizations, and so that is well documented, well thought through, and you have a good guideline for the testing. Here's some examples. On the right side, you see nail penetration test, excuse me, and a crush test in the middle, and some other typical test devices for deforming or abuse testing of a cell. Okay, and then we come to the materials test. So here, as mentioned before, we're looking at all the elements of a cell, the anodes, the cathodes, the foil material, the active material that is being coated onto the the foils, separator foil, the pouch composites, tabs, vents, the containers. And here we typically look at smaller forces ranging up to 10 kilonewton about. So here we cover the full range of tests that we see that we can do with our mechanical testing machines: tensile, compression, flexural, puncture, stiffness, creep, and so on. One particular test is the adhesion strength measurement. This is the adhesion strength between the coating and the electrode. We do other tests like seal seam strength, but also hardness testing, elasticity, nano indentation, and so on. Here's some example that we see also later on. Okay, here we have put together an overview of different types of tests for the different test areas, like materials testing, structural testing, functional testing, abuse testing, but also which types of tests are being used on a cell material or cell component level, and then on a cell level. And just to show you how to read this, for example, if you want to understand where tensile testing is performed on what kind of cell materials or cell components, you see, for example, tensile testing is being done on electrodes, on separators, on tabs or connectors, on the pouch itself, on the cell structure, but also on the container side of a cell. Okay, this just is an overview which can help you to identify some areas where you still might consider some testing. Okay, to sum up the types of tests again, so we're doing tensile tests, performing compression or crush test. We can apply a torsional loading on the cell structures. We do adhesion and peel testing. We do the swelling tests during charging cycles, flexural impact testing, to fatigue and impact testing, nail penetration, hardness testing, scratch testing on a nanoscale as well. And we do all kinds of functional testing where we combine different signals from the cell with the mechanical properties measurements. So let's get now to the tests we were mentioning. So we're going to show you now some tools that we can provide to characterize the different materials of a cell. So the first test to discuss is the puncture test, which is used to determine the resistance of a film or laminate to the penetration of a probe at a slow speed. This test method imparts a biaxial stress that is representative of the type of stress encountered in the product at the end of use, of applications. Typically, the maximum force at break, penetration distance, and energy to break are determined. And this is a fairly standardized test. It's being derived from the plastics industry and can be fairly well adapted to the requirements of the battery materials testing. I've listed on the left side a couple of standards which can be referenced or can be related to for this kind of test. They apply to not battery cell tests, but to other related tests for the plastics industry, paper industry, metals industry, and so on. So it's kind of a cross-reference to other standards in the industry. So puncture test, important and interesting, and can be done with our universal testing machine. Then the most important test and the most known tests anywhere is the tensile test. Here we offer, let's say, the tests on any kind of materials that are being used in the cell. It's used for determining the mechanical properties of those materials, primarily for the engineering design. Research and development is looking at new materials to understand new material properties. It helps in simulation of real conditions, can be combined with media or temperature conditions. It helps to simulate, to validate simulation processes, and it helps in production process and in the quality control process to improve performance. A classical application, of course, depends on the standard and on the material, but typically we're looking at strip or dog bone samples with a various range of speeds that are given by the standards. So we need to make sure that you choose the right speed for your application. And especially if you compare your results with other laboratories or your supplier or your customer, make sure that you define all those test parameters very precisely so that you can actually compare the test results. Which results are we talking about? So typically maximum tensile strength, elastic modulus, yield strength, RP02, and also strain at break. Then we're looking at the sealed seam strength. This is a test derived from the packaging industry. The sealed seam strength is predominantly important for pouch type lithium-ion battery cells. The sealed seams of the pouch laminate keep the cell protected and they keep it tight. Therefore, the materials and processes need to be well controlled, and the tests need to ensure a safe lifetime cell performance. So it's a very important test for pouch cells. Again, the application is similar to the tensile test, so every testing purpose is similar to the tensile test. The application, you cut out a sealed seam and then pull it apart in a 90-degree tensile test, typically the speed of about 100 millimeters per minute. And then you're looking at a first separation force, average separation force, and the maximum force. And you also need to consider the visual inspection of the break and understand whether the seam has failed or the material or the foil has failed. So it's also visual inspection that is required. Then we're coming to a test which is very important. It's the adhesion strength determination of active material coating on electrodes. And there are many parameters that influence the quality of the test results, such as you need to use an adhesive tape, and so the tape quality is important, but also the bonding time and the bonding pressure that you use to ensure the adhesion test. So the test is fairly easy to use, good for a quick check, but in the end is not extremely repeatable and difficult to reproduce because there's so many influencing parameters which play a role. So again, test speed about 100 millimeters per minute. The minimum maximum peak force is being looked at, and also the average force is being determined. So a fairly standardized test, giving some indication of the adhesion strength quality of the coating. An alternative adhesion test is the Z-direction tensile test, which was derived from a test in the paper industry. Here, the testing process is kind of fully automatic, and the machine eliminates the flaws of the peel test. The test fixture, this test fixture allows to program the relevant parameters, especially the bonding pressure and the time, bonding time, as well as the test speed, and thus reduces operator influence quite significantly. The rest is a clear single data point. The result is a clear single data point. So we're looking at maximum strength, and this test is well reproducible. One other good feature of this fixture is that it actually offers you 5 statistically useful tests with only a one-time sampler preparation. So it really is a very efficient tool for this kind of test. If you're interested in this test in more detail, then please do not hesitate to join us for tomorrow's webinar, where we will compare the adhesion tests with the adhesion tests with the 90-degree peel test fixtures and the Z-direction tensile test fixture. We'll go into more detail about the differences of those two tests. Then we're looking at the friction test, which is used to determine the coefficient of friction, and it helps to characterize the interaction of the electrodes, coating, and separators during the production process. And the obtained results help to tweak relevant process parameters to improve quality and efficiency in the production process. So here we're looking at static and kinetic coefficient of friction values, and that helps in the production process. The two-point bending test is used for the determination of the bending stiffness, and it's used to characterize the behavior of coated electrodes during the production process. So we are bending the coated electrode up to 7.5 or 15 degrees, and can determine a bending resistance, which gives us information about the bending stiffness of the sample. And again, here, this test is used to understand some relative process parameters and helps to improve the quality and efficiency in the production process. The last test to share with you today is the compressibility test. Here it's used so that it gives us an indication of the deformation and remaining deformation of a coating after specific load is applied. So depending on the required accuracy and resolution, we typically offer two types of testing tools. The one that we show here is the compressibility measurement head, and alternatively, for very high accuracy, high resolution compressibility tests on nano scale, we offer our Nano indentation hardness tester. So here as well, this gives qualitative and quantitative information about the quality of the coating. It helps also to understand how the coating is aging over time and how it changes its mechanical properties over time. And yeah, so the test results typically are compressibility, recovery, and resiliency measurements. Okay, so to sum up, all these tests actually can be used with our testing machine. Here we offer load frame capacities from 2.5 up to 150 kilonewton or even higher, depending on the requirements, depending on the standards that you want to follow. We offer dedicated systems which perform one single test, or we offer universal test systems which can be combined with different types of tests. We offer different load frame sizes. Depending on the specimen size, can be either extra wide or extra high load frames, and we offer the required testing speeds that are required for the abuse tests, which can go up to 5 meters per minute. So as mentioned, the tools that we saw before, you can integrate them into our load frame. We also offer the sample preparation for some of those tests. Additional sensors like optical extensometers can be added to the load frame and connected to the machine, as well as high-speed cameras, which are required for some abuse tests where high-speed cameras are required. We can also connect or read in additional signals from battery analyzers, and can share our data as well with external systems. All this is being done with our TestExpert 3 software, which is the heart of the machine, and here all the configuration is happening and is allowing the configuration of the different test types. For specific tests like the abuse tests, where the machine has to be in a specially protected environment, like a special container or a special room, we can provide remote operation. So all the electronics and the control tools are being outside of that control room, and can then remotely control the test in that room. We offer additional temperature chambers, which allow to run tests at different temperatures as well. We can also ramp up these temperature chambers to allow for some protection function for abuse tests, for example. So we can offer these chambers up to safety, up to a hazard level of 6. And we can also offer some tooling and some solutions for sample manipulation in case a cell is going to thermal runaway and needs to be evacuated from the testing machine. So all this together gives you a good overview of how universal our testing machines can be.